Lunchtime.
Hi, everyone on Zoom. Thank you so much for joining us. We're going to start in a few minutes. So if you have a second, please feel free to kind of fill out this attendance form. Right. Mhm.
From CCV?
Yeah.
Do y'all use UV?
We've all switched to UV.
You've all switched?
Yeah, yeah.
Okay. They can endorse
And I think the whole ecosystem is also like switching to
it. The
UV.
whole bunch.
The entire Python community, yeah. Yeah, it's getting very, very popular now.
It's exciting.
Yeah, it is. Finally, we have something that, yeah. Okay, so it's 6 past 12. So maybe let's get started. Hi everyone. My name is Paul Xu, and I am a lead data scientist from CCV. And today we are going to talk about Python tooling. Tooling is an important topic that actually doesn't get talked about a lot. When we talk about programming languages, we usually focus on their syntax, their functionalities, but tooling is actually one of the important aspects that determines the developer experience with the programming language. So if you look at the popular languages, you will see that they usually come with great tooling for developers. So let me move this a little bit away. So yeah, so for example, for C and C++, it comes with great compilers that optimizes the C and C++ code. And you know, for a language like R and Java, they have great IDEs. And for JavaScript, you can probably think of a few good JavaScript linters like Prettier and ESLint. And also like Rust is getting a lot of popularity nowadays, and Rust comes with the great cargo that solves a lot of the tooling issues for Rust. So today we're going to focus on reproducibility. That's an aspect that affect both data scientists and software developers that work on Python. So basically, the reproducibility issue is this. So I have written some code. I want to run it somewhere else. So for example, I have run some analytics code, and I want to be able to. I've done some testing on locally, but I want it to be able to run smoothly also on Oscar. That's one thing. Or if you are a Python package developer, you probably want other people to run your code that you have written. So you want to package up your code and then maybe publish it on like the Python package index PyPI, so that other people can also use it. So this is the problem that we're facing, and in this space, Python tooling was a mess. So Python comes with pip, and there's a lot of like tools built around pip, but they focus on this one thing, which is dependency management. But then built on pip, we have some other tools that solve the problem of project management. For example, like Poetry, like Hatch, like PDM. I remember that every time I like listen to a Python podcast, there's a new tool that is on the block. But all of these tools have some advantages and disadvantages. So there is no consensus on like which tool that we should use. And also there's this issue with managing the version of Python. And for that, you have PyEnv. Poetry and PDM, these tools don't usually handle Python version management for you, so that you're stuck with whatever Python version that you installed on the system. And also, in order to create virtual environments, you have like venv and virtual env. And also, in order to kind of publish your package, you have to. If you have used some older packages, you might see a setup.py that basically is a definition on how to build, and then if you want to publish the package, then you will use another package called Twine, and that will help you to publish your package on PyPI. And if that is not enough, you also have another set of tools built around Conda that allows you to use Conda virtual environments that actually kind of you can specify the Python version for Conda environments. So all these tools was creating a huge mess. So so if you're a Python developer, you might have to use all of these tools. But how can we actually just use one package one tool that does all this and a little bit more. So this is where UV comes in. So basically, the philosophy of UV is this. Yeah, so you have all these tools, but we don't want to kind of learn all that. We just use one tool to manage to do what all these tools does. And at the same time, since UV is written in Rust, as you can see, that's how they advertise their package. So UV is blazing fast, and it is actually much faster than any of the tools that we mentioned above, and in terms of package installation. So basically, that's the philosophy of UV. UV comes from this company called Astral that actually does a few other great Python tools with Rust. So if you have used Rough, that is basically built with the same philosophy. So with Rough, it replaces a series of other tools that does Python linting and formatting for you. So basically, let's do some comparisons. I feel like basically UV is just a replacement to tools like Poetry or PDM or Hatch. So UV is basically in the Python package management space. So if we want an apples to apple comparison, so for when compared with UV, well, when compared with Poetry, so first UV is much faster, as we saw just now. And it also uses a standard PyProject.toml format. So that makes it easy for you to switch in UV and switch out of UV. With Poetry has its own PyProject.toml format, which makes switching very difficult. And another thing that UV does that Poetry doesn't is that it manages Python versions for you. So you are not bound to what Python versions installed on your system. And it has better dependency solving. And in order for you to kind of like switch or migrate from Poetry or any other tools, UV has this great pip replacement that basically allows you to run UV as a drop-in replacement for pip. So that you can gradually move your code base from whatever it used to be to UV. And also, because UV solved this many problems, it is gaining a lot of popularity in the Python community. And it seems like the entire community is gravitating towards using UV as the standard tool for managing Python packages. So, how about UV compared with Conda? So for Conda, actually Conda is a different kind of tool. It is, instead of being a package management tool, Conda actually only focuses on managing the environment for you. And also like Conda is plugged into a different ecosystem and developed with a different philosophy. So basically, Conda has its own package index. So basically, you need to build, if in order to publish to Conda, you have to build your package separately and then upload to Conda. It offers you different tooling for building these packages. So in that sense, UV is only used with PyPI, and you can specify different your custom indices, but UV does not work with the packages in the Conda ecosystem. And Conda is not built just as a Python virtual environment manager. It actually manages system packages, and you can also install packages. You can install other languages. You can install other packages for other programming languages. So in that sense, Conda versus UV is an apple to orange comparison. So UV is very different from Conda. So there are still situations you might want to choose Conda versus UV. So in order to decide when to use what, here's our recommendation, and this is actually the kind of philosophy that I live by, which is if you need anything from Conda, then you use Conda. Because there are certain packages that are only available on Conda, or maybe on Conda the installation is much easier. It comes with all of the necessary dependencies that are only available on Conda. So if there is a package that recommends you to use Conda, then you use Conda. Or if you need a different environment, virtual environment manager, and you want to use multiple languages within the same virtual environment, then you use Conda. Or there's another situation where you're on a system where you cannot install like system level packages, for example, Oscar. Then you might want to use Conda to actually install some system level packages for you that you wouldn't otherwise be able to install on that in that environment. So yeah, so these are very specific cases where you might want to use Conda, but in all the other cases, right now the recommendation is that you can use UV. Yeah, so UV gives you all different functionalities. So you might use just a little of them or all of them, but UV is becoming that good as the time goes on. Okay, so that's basically a little bit of introduction of UV. So I'm gonna do a little bit of a demo on how to use UV, but before that, for Oscar users, we also have some recommendations. So first is that we do advise that people not to use Conda. Even now, we have Mamba that makes like package installation much faster. We don't recommend using Conda or Mamba if it is possible. If you don't have any specific reasons listed here that might prompt you to use Conda, then you probably want to stay with UV. But on the other hand, UV is not available by default on Oscar. So UV is not available as a module, so you cannot just do module load UV on Oscar for now. But from our experience, since UV is written with Rust, it is actually built into it is actually compiled into like binaries. So you can simply download the UV and UVX binaries from the GitHub releases, and then just copy them onto Oscar and then put them on path, and you can start using UV directly. And I'll show a little bit on how to do that. Actually, there is a script that you can use to actually get UV on Oscar. Yeah, so now I'm going to do a little bit of a demo, and please feel free to follow along. And you can use git clone this repo onto either your own system, or you can follow me on Oscar. Yeah, either way, totally fine. And while people are getting set, any questions so far? Okay, so yeah, here, this is the repo, and if you just read the README file, I'm just going to go through this README file so that we can go through the installation, how to use UV to kind of manage packages, and also how to use UV to build your Python package and publish to PyPI. And if you're interested in the slides for today, the link to the slides is also available in the repo.
Good.
Okay, so let's get started. So there is a few ways for you to install UV depending on your system. But our only recommendation is that uh, do not, while UV is available via pip, do not use pip install UV because you want to use UV as a system package. So the correct way to do it is either through an installation script that UV provides on their official website. And it's the same kind of line of command that I have here. Or you can use a system level kind of package installer to install it. So on Mac OS, if you have Brew, you can use Brew install UV to install it. The downside of using Brew to install UV is that you will not be able to use UV self update to actually update the UV version itself. You will have to update UV through Brew. But Brew installation is a little bit easier than downloading this installation script and execute it. And on Windows, there's this command that you can use to install UV through PowerShell. And if you're interested in installing UV on Oscar, I have a installation script in the same repo. And if you run that script, you will be able to, basically that script does is to go to the UV GitHub repo, download their released tar file, and then extract the UV and UVX binaries to your local bin directory and add it to your path. Um, it is um, it is pretty easy to do that. And after that, if you just do source bash profile, then you will have UV available on your command line. So as you can see, I'm already on Oscar. So if so whenever you have you've gone through the process to get UV installed, feel free to use UV dash dash version to verify that you have UV correctly installed on your system. The latest UV version right now is 0.9.8. So let me just show you a little bit of this the script. Hold on one second. So you can basically define what UV version you need. So you can just kind of change the version field here and then run this bash scripts. And then in this repo, basically, I just have a little fun package called MooJoke, which basically uses like basically gives you a cow that tells you a programmer joke. And then we're going to go through like how to use UV to install packages and manage your dependencies, starting from the very easy step. Okay, so first, one different thing that UV has against all these other package managers is that it manages Python versions for you, which is very useful, especially on Oscar. So for example, like the Python, there is a default version of Python on Oscar. I think the version is 3.9, right? But 3.9 is already out of the maintenance cycle. So if you use UV, then you can install Python with a simple command right here. Oh, come on. Yep.
I'm looking ahead a little bit, but
Mm-hmm.
in your repo, I don't see any reference to open on demand. So I'm wondering if you're gonna get to how to use this open on demand, and right now in particular, if that anything about installation has to be different to use OOD.
With open on demand, okay, that's a good question. All right, so yeah, I actually don't have that kind of included in this repo, but I'll touch upon that a little bit. So basically, with open on demand, you create a Python virtual environment, right? I assume that you're using UV. Are you using Python open on demand Python notebooks, right?
Python notebooks with DSCoV.
Okay, so yeah, so in terms of that, so basically, if you're using it with notebook, VS Code, it's basically the same thing. It's basically you just get UV installed, right? And then via the command line, you already have UV. So you can just use UV as basically like another module that you load, but it's already installed there. So so yeah, so you can just UV as usual. And if you want to use Open On Demand with the Python notebooks, you can use UV to create a virtual environment and then basically install all the packages in there. You can use that. You can use pip. You can use UV pip for that. And also another way is if you already have a PyProject.toml file that's managed by UV, right? So then if you do UV sync, for example, then a virtual environment will be created within that directory, right? So when you are starting the when you're starting the notebooks, just specify the path to be that virtual environment. And then you should be able to use all of the packages in there. So yeah. Yeah, so you can use UVPython install to install like Python versions. So for example, and the good thing about this is that after you install a version of Python, actually, I actually made a mistake. So let me just actually go back to uh, okay, so I was in the DSCoV UV directory, and there is a Python dash version file that controls the Python version that specific package needs. So when I run UV Python install, it picked up on that information and installed Python version 3.11. But by default, it will install the latest version of Python, maybe -1 minor version. So if you do UV Python install out of that directory, so it usually installs Python 3.13 for you. for now. And I think as 3.14 gets more popular, it will be 3.14. So the good thing about this is that the Python installed will be available directly to you. So it is managed by UV, but you will be able to use it. So for example, I have already like Python 3.13 installed. So if I do, for example, so this Python 3.13 version is actually what UV installed for you. So that means from now on, you don't need to do module load on Oscar anymore. So you can just directly use this Python version that that UV just installed. And just now UV also installed the Python 11 version. So if you issue the 3.11 command, I think you will also have access to 3.11. So yeah, so yeah, so UV can basically manage any Python version for you. In this README file, you can see that you can also install the free-threaded version that comes with the latest version of Python. So basically, these versions do not have a global interpreter lock that allows you to kind of like use that allows to multi-threaded program to execute much faster. And the way to install it is UV Python install 3.14 T. And this T tells UV that I want this free-threaded version. Yep. Okay. So yeah. So this is one of the strengths of UV. You can actually manage your Python versions globally. And okay. So let's go back to the repo. So now let's focus on like one of the another strength of UV, which is you can actually just use it as a pip dropping replacement. You don't have to buy into all the functionalities that UV provides. But if you simply just want to have a faster pip, you can use UV pip as as a drop-in replacement for just pip install, for example. So the syntax is exactly the same as how you would use UV. So basically, as you would use pip. So basically, you can do pip install. For packages that come with extras, you just add this square bracket right there. Pip uninstall also works. Pip show, pip freeze, and even like the good old pip install -r requirements.txt also works. Yeah, one thing to actually to note is that you usually need to kind of create a virtual environment with UV first, and the way to do it is with UV VM. And then basically it's basically like running like Python -m VM to create a virtual environment. So UV creates this virtual environment for you, and it's by default at this within this directory, and you can basically activate it with this command, just like any other virtual environment that you have created with Python -m VM. Yeah, and then subsequently, if you install any package, it will be installed into this virtual environment. So if I do UV pip install, for example, fast API, as you can see, it runs very fast. It resolves all the dependencies for you and install them. Yeah, so if you use source, okay, source.vtnv, then activate, just like how you use any other virtual environment, you can do that, and then you will find that fast API is installed there. Yeah, so as you can see, the fast API is there. I just didn't give it enough command to actually have a, for example, a fast API server start. So this is one way you can use UV with like open on demand. So if you want to launch a if you want to, for example, like build this virtual environment and launch the notebooks from there, you can basically just do that. I think there is documentation on the Oscar documentation provides like how do you like install like how do you build an environment with pip, but you can just replace all these pip commands with UV pip, and that's basically it. Yeah, go ahead.
How do I cross-manage, like, I want to pip install in a certain version? Are you gonna go over that? Or, like, for
Pip
certain-
install with a certain version. Yeah, I'm gonna go through that. So yeah, yeah. So the question was, how do you manage? How do you specify different Python versions while using pip install? And the way to do that is with this Python version file. So you just keep it in the directory where you keep your package, and then this will tell pip will tell UV which version to install. So for example, I just clone this repo. Okay, so let me do cd. Yeah, and then you again, so within this folder right now, there is not a virtual environment set up yet, but you can also do UV VM.
So that sets the version
Yeah.
of the virtual environment.
That sets the version of the virtual environment, the Python version that you use. Yeah.
So I guess what I'm getting at is, so
Mhm.
you're expected that like you're probably going to be using one version
Mhm.
inside the particular directory. You're not going to be mixing and matching.
Mix and matching, I don't think so. For that, you are going to have to create different virtual environments and switch. Yeah. Mhm. But one thing that you can do is that, so for example, if you have been like developing with 3.11, for example, right? But if you want to change it to 3.12, you can just change this file, and then UV will change all of the dependencies for you. Yeah. Okay, so let's go back to the README. Yeah, so this is basically the very basic way of using UV. If you don't want to buy in, then you can just use it as a drop-in replacement for a drop-in replacement for UV for pip. But UV really shines as a package manager. So so let's use UV as a package manager, and this shows you how to do it. Again, let me just get out of this folder because there is already a package there. Let's just switch to another folder. So for example, let's just go back to CD. And then you can create a package there. So for example, let me just use UV init and then to create a package there. And there will be a new directory set up, and then you can cd into it. And a few files will be created here. So you will see that you have a main.py there. You have a pyproject.toml. Basically has some information about your project. So you can fill it out, and based on the Python version that you have for your system, it will also kind of specify the Python versions. Of course, you can change all that. This is how we recommend how you start a Python project. You can always use UV init to create a folder, and if you already have a folder, you can actually just use UV init, and all these files will be initialized right here in that package. Yeah, so these are the files that UV will create for you. So a pyproject.toml, a main.py, which is basically a hello world kind of printout, README, and a Python. So yeah, so this Python-version file basically specifies what kind of Python you want to use locally. So with this, UV will basically get you the right Python version and install the correct dependencies. And that's it. That's how like you create a new environment. I did mention that whenever you create a new whenever you create a new project, a virtual environment will be automatically created for you too. That is available at .venv directory. And more, here's some bonus content. So basically, more and more package developers are actually providing kind of programs for you to actually create new projects that is like a template for some other more kind of complicated programs. So for example, Fast API has this utility called Fast API New that basically allows you to create a very basic Fast API program. And you can have access to these tools via the UVX command. So UVX is basically a tool for executing Python packages as tools. Today, we're not going to get very deep into it, but what UVX does is that it on the fly creates a virtual environment, download all of the dependencies that this tool needs, execute this tool, and then delete everything for you. So basically, if you want a one-off execution of some Python packages, you can use UVX.
All the downloaded stuff?
I think it does. So if you want to use it again, then it will quickly just recreate that environment for you again, and then do that. So UV does Python. UV does caching like very smart. It has like it saves a lot of like caching spaces for you as well. So yeah, the way it handles like caching is very smart. Yeah.
It's blowing my mind.
Sure.
Wait, so you could use this as, like, say you have a command line program.
Yep.
Like to start a tab or something like that.
Mm-hmm.
I could use UVX to distribute it and just be like, hey, download UV, type this one command.
Yeah.
And then it'll run command line.
Yes, you can
Okay.
define. Yeah. So the question is,
That
so yeah, if I have developed like a Python package, for example, available as a command line kind of a command, right? Am I going to be able to use UVX to actually let people use it without downloading anything, right? Yes. The answer is yes. So for example, you can use, for example, rough is a program, right? So you can do UVX rough. See, it installs everything for you and then execute whatever that command is. So yeah, so that's another way for you to kind of distribute programs that can be used as tools. So what they define Python tools is that basically it's just a package that has a command line interface. Mm-hmm. Yeah, and then so let's talk a little bit about how to add dependencies and remove dependencies. That is very easy. You can just use UV add and UV remove. This is exactly the same as poetry. The way to so for example, I need these two dependencies, so I just do UV add pycalc. Yeah, and then UV add pyjokes. Please ignore these warnings. It works. It just warns you about some linking issues, but yeah, don't worry about that. And if you want a package as a dev dependency, so you don't want your users to actually directly interact with these packages, but as a developer, you probably need rough, for example, for linting and the formatting. So you can add a package as dev dependency. So you can just do --dev, and then let's just take a look at the PyProject.toml. As you can see, so yeah, so UV basically added PyCalc, PyJokes as the dependencies, and then rough as a dev dependency. Basically just by like adding and removing things from PyProject.toml. Yeah.
The interaction between UV add and UV pip install.
Mm-hmm. Oh yeah, so that's a really good question. So UV pip install basically is like a replacement for pip, right? So if you do UV pip install, you can install a package, but it will not show up in PyProject.toml. So that's basically the difference. It is not tracked by UV.
But everything you add, you then do sync, if you then do lock and sync,
Mm-hmm.
it will be as if you had pip installed it.
It will be, yeah, exactly. So yeah, so the only difference is that, so the packages are not synced to PyProject.toml. Yeah, that's the only difference. So basically, you can this is how I kind of conceptualize it. It's basically like UV pip is just a kind of utility for you to kind of like, if you don't want to use the full kind of power that UV provides you, I'm familiar with pip and I just want to use pip, then you can use UV pip as a kind of as a replacement for it. But if in order to use the full power of UV, I definitely recommend just use UV add and UV remove. Yeah, and you're right. So if you have the PyProject.toml and when you do UV sync, which we're gonna touch upon a little bit, then UV sync basically kind of just installs everything with whatever that UV pip kind of does and installs all those packages. Yeah.
Ask a question about the Toml project.
Sure.
So
Yeah.
you did UV add rough, but then it had version lower bounds.
Yeah.
In total. So so anytime I add a project or a package to my Toml, then is it going to like automatically rerun the dependency tree or like figure out the bounds?
Yes.
Every
Yeah.
time?
Yeah. So yes. So basically, what UV does is, so the question is, when I added a rough, I did not actually specify a version, right? But then in PyProject.toml, as you can see, there is already some like version constraints there. So the question is, does UV actually just do that? Does UV resolve that dependencies for? Yes. So UV basically based on all of the dependencies that you have, and then goes on to kind of like PyPI, and then and then kind of gives you like a version resolve like that will work with the rest of the packages that you have. And if it cannot find a version that it will be able, it can work with, then it will give you an error. It basically says that, yeah, based on all of the other dependencies that you have, I cannot find a compatible version for you. Yeah. Okay, yeah, so some more advanced use of UV add. So there are packages that offers extra. So for example, whenever you see this square here, that means the package comes with a few extra packages that you need to actually specify so that they will be these dependencies will be installed. You will see a lot of packages that comes with this kind of instruction. With UV, you cannot do that anymore, but you can do UV add fast API with dash extra standard, and then it will install all these extras for you. And you can definitely specify version constraints yourself. So for example, if you maybe as a data scientist, you just want to use a NumPy version that is lower than 2.0, for example, then you can do UV add and then put this version constraints in quotation marks. So sorry, I missed one quotation mark here. Yeah, and then you can also add packages from GitHub. So you can do UV add git plus and then add the direct the address of the repo. Yeah, and then let's move on to so I've added my dependencies. I've written some Python code based on it. So I want to be able to run it. And then the way to run it is very easy. You just run UV. You just use UV run. So basically, whenever you preface with any of the commands that you would usually run, then UV will run this Python script or this package within the virtual environment that you have created. So basically, that means you don't have to activate that virtual environment to run these things. The way to do it is with UV run. So since I have a main.py here, so I can do UV run main.py. And you can see that it does this hello world for you. And you can also do UV run rough. If you have already installed some packages within the virtual environment and you want to be able to access them. So for example, we just installed a rough in there. So we can just do UV run rough, check and dot. Yeah, so then it will run rough from within that virtual environment. Again, you don't have to activate that virtual environment. And that's how basically UV works. Usually you don't need to activate that virtual environment that is created. UV will run everything from there for you. Okay, now let's focus on another problem, which is if you have run some code and then you have specified some dependencies, you want other people to be able to use it, or you want to be able to run it somewhere else. So then you want to be able to sync dependencies, and this is what UV does. You can do UV sync. So for example, let me just switch back. Yeah, so this directory actually has a UV managed Python package in there, and if you check out the pyproject.toml, you can see that there's some dependencies defined. There's the dev dependencies defined as well, and there's some other meta information that we'll mention a little bit later. Yeah, but so the way to actually basically have UV install all these dependencies that you have specified is just UV sync. And what this does is that it creates a virtual environment and syncs all of the dependencies that you have just specified in pyproject.toml, and that's it. And you can see that here, the Python packages that you define is installed for you, and also all of the dependencies are installed for you as well.
Sorry, what do you have to transfer? I think it was the step.
Mhm.
What do you have to transfer for that to work somewhere else?
The only thing that you need is pyproject.toml. So everything, yeah, all these metadata, all this information is saved within pyproject.toml. Yeah, the question is, what kind of information do I need to kind of carry over so for this thing to work? And the answer is we just need that pyproject.toml file. And UV will usually also create a uv.lock file, which actually specifies exactly what kind of version and packages installed in the current version, virtual environment. So if you want the exact same configuration to work, then you can also kind of sync. You can also transfer the uv.lock file as well. But sometimes that will create problems. So for example, if you're on Mac OS and you want to transfer to Linux, and then the dependencies might that the same configuration might not exactly work. But in that case, you can just transfer pyproject.toml. Okay, we're about at time, so let me just quickly go through these processes. So first, you can use UV to build a package. And actually, in the newer versions of UV, it actually comes with its own build system. So basically, the build system is the kind of like tools that you need to build a package into build your Python package into, for example, like a wheel file, so you can distribute it later as a real Python package, right? So you need to add this part into your pyproject.toml to specify what kind of tools that you need. Basically, the most important definition is the build backend. And now UV comes with this UV build backend itself that allows you to use UV itself to build packages for you. And once you have, so you just basically add this to your pyproject.toml. You might have just seen that one in these lines in pyproject.toml within this folder. So let me just run UV build. Yeah. So whenever you have this set up and your environment is configured correctly, then it will build the wheel for you. So basically, it will build your package your source code in this file, and then also build a wheel file. It is really just that simple. There's no extra configuration needed. And lastly, if you want to publish it, the command is UV publish. You might need some configuration there. We're not going to get through that since this is a fake package. We don't want to actually build it on PyPI. But if you want to try the publishing functionalities for UV, you can just use UV publish, and you might want to also add this part to pyproject.toml. That basically configures a test PyPI as a package index that you want to publish your packages to. And then if you run this command, UV publish, if you're actually publishing your package to PyPI, then the only thing you need is UV publish. But since we're not actually publishing to PyPI, we're publishing to test PyPI, we need some extra configurations. So that makes it a little bit more complicated. But still, that also shows UV can support multiple package indices, not just PyPI. Okay, that is about it. I think that's all of my demo for today. Thank you so much, everybody. I'll still stay here for questions if you're interested. Yeah, again, thank you so much for joining us. Have a good day. Right, thank you. Okay, so there, I see a chat message. All right. Thank you. Our only live attendance. Yeah. Seems like everyone has signed out on. So okay. So let me